In our discussion of integrals, we have established that an integral can represent the area between a curve and the x-axis. So let's look at what happens when we want to find the area of the region between two curves. So as long as we have a curve, f, say, that is greater or constantly above g on our interval from A to B, then we can say that the area of the region between the two curves, considering we have a curve on top, this upper curve, and a lower curve on the bottom. All right, so above and below. We're still going to consider those bounds and say from A to B, right, A to B, it's just that we have the upper curve minus the lower curve. Okay, so whatever integral is on top, that's going to come first. And then whatever integral is on the bottom, you're going to be taking that area away. So let's look at a basic example. So here we're going to find the area enclosed by the parabola y equals 2 minus x squared and the line y equals negative x. The first thing we should do would be to look at the graph. So I've created a graph for us here. The area of which we want to find, or the region of which we want to find the area, is what I'm shading here in yellow. Okay, so that's the region that we are looking to determine the area of. So what we need to do is determine my points of intersection. So I know my horizontal region, right? I know my interval. And in this case, my interval is going to go from -1 to 2 because my first point of intersection is -1, +1. My second point of intersection is +2, -2. So I'm going to use those as my bounds of integration. You'll notice the parabola is the upper bound, or it's the upper function, and then the line is the lower function. So remember, when we set this up, we're going to have above minus below. So in order for me to set up my integral to calculate my area, this is going to be the integral from -1 to 2 of 2 minus x squared minus, my lower one, is -x. Okay? And one question I get here is that, part of this is above and part of this is below, and why don't we have to include absolute value? Well, when we are subtracting, if we're subtracting a negative region, subtracting a negative makes it positive. Okay, so we don't need to use absolute value for area between two curves. That's only when we're trying to find the area of a curve and the x-axis. So pause the video if you're not certain. Make sure you understand how I determined my values and how I set this up. Because at this point, it's a pretty easy integral for us to calculate. And one note, determining those points of intersection. In this case, it was really easy for me to see on the graph, but if you didn't know how I found the -1 and the 2, if you didn't have a good graph, you would just set the two functions equal to each other and solve. And of course, that square shouldn't be there. So solving this, we would have 0 equals x squared minus x minus 2. That would factor x minus 2, x plus 1, and that's where I get x equals 2 and -1, which are those two values I used for my interval. All right, so I'm going to rewrite this on the next slide, and we're just going to calculate the area between these two curves. So here's the same integral that I had on the previous slide. And what we're looking at here, and one thing I want to make sure and point out, in this case, there's only one term in that second function, the one we're subtracting. But if there are multiple terms, you do need to make sure that that minus would distribute to everything. So I re-emphasized, I put some extra parentheses in there to let you see. We have our top function minus all of our bottom function. So this simplifies, and that would be the integral from -1 to 2 of 2 minus x squared. That would become plus x dx. And this becomes very easy for us to integrate. 2 becomes 2x. Negative x squared becomes x cubed over 3, and x becomes x squared over 2. We need to look at evaluating this from 2 to -1. So I will plug my 2 in first, which gives me 2 times 2 minus 2 cubed over 3. Doesn't look like a cube. Plus 2 squared over 2. And we need to then subtract what I get when I plug in -1. So that would be 2 times -1 minus -1 cubed over 3 plus -1 squared over 2. Make sure you're using your parentheses. Those are going to be your friends here. So that first piece, let's see what we get. I have 4 minus 8 thirds plus 4 halves, and 4 halves is 2, minus -2, that would be remain -1 when I cube it, so negative, that would be plus 1/3. That would be +1 when I square it, so plus 1/2. And calculating these values, adding them together, I get that the area between the curves is 9/2. And so there we have it. That's an example of finding the area between two curves.